Alrighty, we are live, boys. Stream is healthy, stream settings. Cool. Okay, so we are going to continue our implementation of Mqtt. Oh la la. Cool. I know, man. PC. I should give the rook. So where were we? So if I remember correctly, we basically figured out this union thing and we implemented the connect thing. Next is basically Mqtt. According to the documentation of Mqtt, so this guy just wants us to read through the official documentation, which is of no problem. We implemented this. I was on the part of figuring out how did they extract these things right from this connecting. So fixed header, variable header, payload. This is good. Fixed variable payload response action. Okay. How many do we have? Like 14. That's okay. Understood. That's not much. Let's just see what he wants us to do. Connect looks like this. Connect looks like this. On the definition of other packets are trivial by reproducing the pattern according to the documentation of this. We proceed with subscribe, unsubscribe, and publish. We proceed with the subscribe, unsubscribe, and publish. Subscribe is the only packet with a dedicated packet definition. Next in our list is connect publish. Is it subscribe, unsubscribe, and publish? I see subscribe is here. Okay, this is part continue. Pubback, publish message, pubback, pubrec, pubrel. rel बोले तो ping request. Cool. Mqtt subscribe. Mqtt publish. So he says like publish should be implemented. Okay, let's just see if we can figure it out. Publish itself. So the thing is, public has fixed header, variable header, payload, response, actions. Okay, gotcha. A publish control packet is sent from a client to server, of course, or from server to client to transport an application message. Seriously, it goes both ways. I thought it was from the publish was supposed to from client to server. Oh, that's new to me. I was under the impression that publish is only from client to server, not from server to client, but it also makes sense from, but that part would be handled by notify, right? Like if server wants to publish something onto the client, that essentially means the server is notifying clients about a message that has been received on server side. Maybe there is more to it that I don't understand. Okay, so the fixed header is nothing but this. A packet type, dupe flag, QoS level and retained. First byte, third bit. I just figured it out. Mqtt header. So this is that fixed header from earlier, right? Yeah, packet ID, topic. Man, I'm not going to able to extract such information from the first code. Now the fixed header is this and states the fixed header format. Control packet type is 3, which means Mqtt control packets, which means this mouse is so fucked up, man. I just can't stand. Structure of Mqtt control packet fixed header. I have to read through these things first to understand what the fuck is going on in here. Okay, so Mqtt control packet types. Mqtt control packet format. Cool. Editing convention. The highlighted text highlighted in yellow within this apply specification defines conformance statements. Each conformance statement has been assigned a reference. The format is what type of reference? There are the things of non-normative and normative references terminology. See, it's important to read through this. I just read from the very first thing, which is organization of Mqtt operation behavior. This is where the algorithm part will come. Then the security using WebSocket as network transport protocol. Cool, man. I hope I'm able to finish this because this sounds so cool. But why am I hoping to finish like somebody else is in control? I don't think so. So I have to understand the packet format first. So that's chapter 2. Then I'll go through the MQTT packet types. Only then I can implement it. Because the thing is I can simply copy paste it, which is fine. For the time being it would work. But I really want to learn how to extract these data structures from the protocol itself. From the specification protocol, you understand, get the point. So I have these specification documentations and I want to able to formulate these data structures. Seems simple, but the process is not going to be that simple. $12. This stream is not going to be too big because why not? Terminologies, I must not required, shall not, blah 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 in the specification are to be interpreted as described in. Man, my tongue is so fucking. Network connection, application message, data carried by the MQTT protocol across the network for the application. Application message means the data carried by MQTT protocol across the network for the application. Okay, so whatever application is running, the data for that application is the application message. When application messages are transported by MQTT, they have a associated quality of service and a topic name. Okay, the message have QoS and a topic name. So each message has a header which says what is the quality of service and the topic name that this message belongs to. It's like tagging messages with some attributes so that some entity can do some processing. In this case, that entity is MQTT broker. So the messages or the packets have these headers, which essentially are attributes, and the broker will decide what to do based on these attributes. So the whole process is something like this overall, that there is some entity which is going to produce these messages, some task, some application, some process, some thread, whatever that might be, and that produced data will have some attribute, and in theory there could be another entity which takes on this data and puts on the attributes, or it could be the same entity that produced the data and puts on the tag, so that because the data producing entity have data producing entity have all the information to tag relevant information on this particular message. You get the point, right? Now there are different entity, let's just say entity 2, which just takes this tagged message and send it onto network or to broker, and then this broker gets this message, and based on the tagged attributes it decides what to do with the packet. Kind of makes sense, the overall thing, right? Client, a program or device that uses MQTT. A client always establishes the network connection to the server, can publish application messages that other clients must be interested in, subscribe to a request application messages that it is interested in receiving, subscribe to remove a request for application messages. So basically it can request or remove, disconnect from the server. A server is a program or device that I'm old, bro. A server or device that acts as a program or a program or device that acts as an intermediary between clients which publish application messages and clients which have made subscriptions. Intermediary is a device or program that acts as an intermediary. So it is an intermediary, means a broker. Intermediary between what? Right. So intermediary between clients and clients. Now, how to differentiate these? So clients that want to publish these messages and clients that have subscriptions. So makes and PubSub model. Accept network connections from clients. A server accepts network connection from clients, accepts application messages published by clients. Application messages published, makes sense, okay. Processes subscribe and unsubscribe requests from client. Forward application messages that matches client subscription. A subscription comprises a topic filter and a maximum QoS. A subscription is associated with a single session. A session can contain more than one subscription. Now the things are getting abstract and I have no idea what this means. Subscription comprises of topic filter and QoS. A subscription is associated with a single session. A session can contain more than one subscription. Okay, so it is like is there any wait for the new thing to come? What? Oh man. A session can contain more than one subscription. A subscription is associated with a single session. Okay, so it's like subscription, session, and there are more than one session in a subscription. There are more subscription in a one session. So it is like session is a bucket and subscription is a balls. And a bucket can have many balls. And each bucket, each ball is associated with a single bucket. See, easy. Since each subscription within a session has a different topic. Wow, that's interesting. So uh, bucket has a filter and bucket has balls. Each subscription within a session has a different topic filter. Now each subscription within a session has a different topic filter. So the ball has a filter. So ball has a filter. This is a bucket. Every bucket has multiple balls and each ball has a different filter. A label attached to an application message which is matched against the subscriptions known to the server. A server sends a copy of the application message. Server sends a copy of the application message to each client that has a matching subscription. And these streams are becoming reading streams instead of coding ones. I don't particularly enjoy that, but this is the process, so embrace the process. What is the topic filter? An expression contained in a subscription to indicate an interest in one or more topic. A topic filter can include wildcards characters. Indicate an interest in one or more topic. A stateful interaction between client and server. Some sessions last only as long as the network connection. Other can span multiple consecutive network connection between Mqtt control packet, a packet of information that is sent across the network connections. Mqtt specification defines 14 different types of control packets, one of which is the published packet is used to convey application messages. Normative reference. Integer values are 16-bit in big endian order. Higher order pipe precedes the lower. This means that a 16-bit word is presented on the network as a most significant bit, most significant byte for one. Text within a control packet described later or encoded as UTF-8 strings is an efficient encoding of Unicode character that optimizes the encoding. Okay, I get it. Structure of UTF-8 encoded strings have any length in the range of byte 1, string length MSP, string length LSP, UTF-8 encoded character data if length greater than 0. Non-normative example. For example, the string A which is Latin capital letter A followed by the code point which represents is encoded as follows. Non-normative. Should I ask ChatGPT? Structure of MQTT control packet fixed variable payload, which we have been reading from last two streams. MQTT control packet contains a fixed header, which is this, and the remaining length. Packet type, control packet type, which is among these flags we have already seen. What those flags are. Comes to remaining length starts at byte 2. The remaining length is the number of bytes remaining within the current packet. Remaining within the current packet, including data in the variable header and the payload. The remaining length does not include the bytes used to encode the remaining length. The remaining length is encoded using a byte 2 is the remaining. Okay, so this is the remaining length. Okay. Remaining length is encoded using a variable length encoding scheme which uses a single byte for values up to 127. Larger values are handled as follows. A least significant 7 bits of each byte encodes the data. Least significant 7 bits. What does that mean? The least significant 7 bits of each byte. Least significant 7 bits of each byte means LSB 7 bits of the bytes. Okay, so just like let's just say this is complete bytes, then these bits, forget the first bit, something like this, right? Encodes the data, and the most significant bit is used to indicate that there are following bytes in the representation. To indicate that there are following bytes in the, thus each byte encodes 128 values and a continuation bit. The maximum number of bytes in the remaining length field is 4. Maximum number of bytes in the remaining length field is 4 byte. Non-normative comment. For example, the number 64 decimal is encoded as single byte. Decimal 64, single byte, decimal 64, hexadecimal this. So 0, 1, 16 चौक 64, 64 ठीक है. Hexadecimal is this. The number 321 decimal equals to 65 plus is encoded as 2 bytes. Least significant first. The decimal number 321 is encoded as 2 bytes. Least significant bit first. The first byte is 6. For example, number 64. Is there anything particular about 64? a single byte, the 2 bytes, and takes the 93. Note that the top bit is set to indicate at least one following byte. The second byte is 2. This allows application to send control packets of size up to 256. The represent of this number on the wire is table shows the remaining length values represented by increasing number of bytes. Size of remaining length field 1 from this to this 7f, that because the first bit is used to indicate whether there are remaining bytes or not, right? This is what this was saying. Most significant bit is used to indicate, wait, the least significant bits means the initial 7 bits. So they are saying, if I'm understanding this correctly, पाँच छः सात आठ 1 2 3 4 5 6 7 8. So if I understand this correctly, then they are saying that the least significant 7 bits of each byte encodes the data. Least significant bits means these will contain, so these will contain data, and the most significant bit is used to indicate that there are following bytes in the representation. Thus, each byte encodes 128 values and a continuation bit. So each byte encodes 128 values. See, so these will 7 bits. So you have like you have like 2 raised to the power. Where is the raised to the power? 2 raised to the power 7, which is 128, right? I mean, I knew it, but just for the purpose of stream. So that's why encodes 128 values, and these are continuation bit. Means if the digit size of the remaining length field, means value it contains, maybe, we don't know. That means if it is 1, then it will be from 0 to 127. $128. I have no idea. The algorithm for encoding a non-negative integer into variable length encoding scheme is as follows. If I take modulus of x, it will be encoded byte, and then I divide it with 128. If there are more data to encode, set the top bit of this byte. Okay, so basically we are saying if the value goes past 120, if the value is greater than 128. So we are saying if the value is greater than 128. Let's just say this is a multiple of 128, which it cannot be because for the, I mean it can be one greater than 128. But let's just say it is 127 or it is 128. If it is 127, then this would be 0, and 127 divided by 128, this is going to be 0, means there are more data to encode than set the top bit. But so in this case the x is not greater than 0, means there is no more data. Now if this is like 129, let's just say, then dividing it by 128, then the remainder will be 1. In that case it is 1. Encoded bytes becomes 1. Then I divide 129 divided by 128 will yield 1 in integer mathematics. Right, it will be 1. In that case 1 is greater than 0. The encoded byte OR, so you are ORing this by 128. Integer division bitwise. Let's just do this later on, right? For now, just understand how to extract those information to form these data structures. What is a variable header? Some type of MQTT control packet contains a variable header component. It resides between the fixed packet header and the payloads. The content of the variable header varies depending on the packet type. Depending upon the packet type. Content of this depends on the packet type. The packet identifier field of variable header is common in several packet types. Packet identifier PID basically 2 byte has, so MSB and LSB. The variable header component of many control packet types includes 2 byte packet identifier. These control packets are publish, pubag, pubrec, pubrec, pubconf, subscribe, something, subscribe, unsubscribe, and publish. Control packet must contain a non-zero 16 packet identifier. I see. Control packet that requires a packet identifier are, what are these? Okay, so they can require packet identifier or not. So connect, publish if QoS is greater than 0. Mostly everything other than the housekeeping stuff. As a result, client-server pair can participate in concurrent message exchange using the same packet. Client and server assign packet identifier independently of each other. Client and server assign packet identifier independently of each other. As a result, client server pairs can participate in concurrent message exchanges. Non-normative comment. It is possible for a client to send a publish packet with a packet identifier of this and then receive a different publish with a packet identifier of and then receive a different publish with a packet identifier of this from its server before it receives a pubag for the publish that it sent. Client publish packet identifier is this. I don't understand. MQTT control packet contains a payload as the final part of the packet as described in chapter 3. Okay, in the case of this variable header has nothing when it decides between the content of the variable varies depending on the packet type. The packet variable is common. Packet type पे depend करता it depends on packet type whether this variable header will have any content or not. Now comes this payload. Who requires the payload? Connect require payload. Otherwise, okay. Remaining length goes to byte 2 is the length of the variable header. Remaining length is the length of the variable header plus the length of the payload. It is encoded in the manner described in this. Okay. Variable header. The variable header. Okay, so I understand. I got it. Somewhat. I just connected the dots. So this variable header, like it says, that depends on the packet type. The content of this variable header. Content of this variable header depends on the packet type. So if I have a packet type of connect, then fixed header is fixed header. We have seen it. Now the variable header for connect packet consists of 4 fields in the following order. So the variable header for this will contain protocol name, protocol level organizer. Apart from protocol packet identifier, does it require packet identifier? No, it doesn't require packet identifier, so it doesn't have a packet identifier. The variable will contain 6 bytes. Six bytes, seventh byte will be protocol level byte. The 8th byte will be connect flags. Oh, so that's how this guy extract these informations, these things. It is protocol name. It is protocol level, so he did not bother with these. I don't know why. I don't know how to take these decisions. How did he know? But then these are connect flag. Connect flag byte contains a number of parameters specifying the behavior of MQTT connection. It also indicates the presence or absence of fields in the payload. Like this is reserved, then clean session. All right. So MQTT fixed header. Okay, so this is the variable header and this is the payload. It reserved clean session will queue as written password username. Reserved clean will queue as written password username. Now this explains these. Variable header. So this is how the variable header will look like. So the protocol name comes here. Protocol level, just like this. Description like level 1 to 4. Connect flags are going to be like this. Byte 8. Keep alive byte 9, byte 10. Now I wonder. Byte 9 and byte 10. Just keep alive. So keep alive is a time interval measured in seconds, expressed as 16-bit word. It is the maximum time interval that is permitted to elapse between the point at which the client finishes transmitting one control packet and the point it starts sending the next. It is the responsibility of the client to ensure that the interval between control packets being sent does not exceed the keep alive value. In the absence of sending any other control package, the client must send a ping request. Okay. Client can send ping request at any time irrespective of the keep alive value and use the ping response to determine that the network and the server are working. If the keep alive value is non-zero and the server does not receive a control packet from the client within 1.5 time. What? And the server does not receive a control packet from the client within 1.5 times the keep alive time period. The 1.5 times the keep alive time period. It must disconnect the network connection to the client as if the network had failed. If the client does not receive a ping response packet within a reasonable amount of time after it has sent a ping request, it should close the network connection to the server. Keep alive value of 0 has the effect of turning off the keep alive mechanism. This means that in this case the server is not required to grant it or blah 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 blah. And so my question is simple, and you can see this keep alive thing, which is of 2 bytes, is falls under this variable header. But why did he decide to do that in here? One thing I can is that it would increase the union size maybe, and the rest of the bytes will go. I mean, cement, it wouldn't look good because the union will get greater than 1 byte. So the getting information by their bit names. Maybe I don't know exactly. Payload of the connect packet contains one or more length prefixed field whose presence is determined by the flag in the variable header. These fields, if present, must appear in the order client identifier. Must appear in the order client identifier and will topic, will message, etc. Client ID identifies the client to the server. Each client connected to the server has a unique ID. Must be each server to identify states that they hold relating to this Mqtt session between client and server. Must be present. Must be the first field in the connect packet payload. Client ID must be present and must be the first field in the connect packet payload. Connect packet. The payload first field, the connect packet payload, must be a UTF encoded string. Between server must allow client IDs which are between 1 and 23 UTF encoded bytes in length and that contains only characters. Server may allow client ID that contains more than 23 encoded bytes. Server may allow client that does not. Okay. The server may allow a client to supply client ID that has a length of 0 bytes. However, if it does so, the server must treat this as a special case and assign a unique client ID to it must then process the connect packet as if the client had provided that unique ID. If the client supplies a 0 byte client ID, the client must also set clean session to 1. If the client supplies a 0 byte client ID and the client session set to 0, the server must respond to client identifier will be the first, which is a UTF-8 string. Will topic, if the will flag is set to 1, the will topic is the the will flag is set to 1, it's here. The will topic is the next field in the payload. The will topic must be a UTF-8 encoded string. So next field, but it is a next field in the payload. Why you are the will topic comes down? If the will flag is set to 1, the will message is the next field in the payload. The will message defines the application message that is to be published. The will topic is described as section 3125. 31. I did not read this, huh? Okay, I think I got the hang of it, or I got bored of it. I think these are coming from, so it is sorted. Outcomes of acknowledgement. The fixed header will look like this, which means control packet type. This is a blueprint. The data will be filled later on. Cool. Remaining length is 2. Means here. This is the length of the variable header. For connect packet, this has the value of 2. Variable header. There is no packet identifier. There is no payload required for connect. Remaining length byte for this is 2, which means I don't know what that means. So the variable header It looks like this. Byte 1, byte 2. Byte 1 is the connection acknowledge flags. Connection acknowledge flag. Byte 0 is the session present flag. And then this is the connect return code. So that is why fixed header. Fixed header. Fixed header. Okay, so let's start like this. This is connect packet. On connect type packet. Here it will have fixed header. There it will have fixed header. What this fixed header will have, what value it will have, that's a different scenario. That's we'll figure out later. But for time being, it got its fixed header. Now comes to variable header, which is going to be just the connect acknowledgement flags, which is nothing but a session present flag, which is of bit 0, and the connect return flag, which is byte 2. Session present is what is this reserved? This is its stat. Fixed header, this is variable header, which contains reserved and session present. Reserved, session present. Then we have whole byte to us as return code. What this value will take, what is the value of this return code is going to be, that's the different scenario. Now comes the payload part. Connect has no payload, so it has no payload. So we have fixed header, variable header. There is no payload. So this was our variable header. This was the payload. Okay. See, the thing that is trivial took me 2 days to understand that it is trivial. Or if I had started from the beginning to read these things, I would have understood better. I guess it's 11:35. Should call it a day. We'll start tomorrow or the day after that with publish messages. So the fixed header of publish messages is going to be like this. Okay, so the fixed header is publish is just a fixed header. Then comes the remaining length is dupe and all. They are covered in the fixed header. Now comes the variable header. Then comes the payload. The variable header contains the following field in the order: the topic name and packet identifier. So I'm guessing Topic name identifies the information channel to which payload data is published. The topic name must be present in the first field in the publish packet variable header. Why are you doing me like this? Listed an example variable header for publish packet briefly described in topic name packet identifier. Must be present as the first field in the publish packet variable header. Sixty-one, 16, 60 and 60 plus 10 plus 6 into 6 means 60 plus 36, 90, 6 or 197, which is A. The payload contains the application message that is being published. The content and format of the data is application specific. The length of the payload can be calculated by subtracting the length of the variable header from the remaining length field that is in the fixed header. It is valid for a published packet to contain a zero length payload. The response action I think reading further would make sense if I go through this first. So the subscribe tuples, pointer to tuples. We proceed with subscribe, unsubscribe, publish. Subscribe is the only packet with a dedicated packet definition. Other can be defined as a generic hack. It's the only packet with a dedicated packet definition subback. Subscribe, I just see subscribe what the subscribe does. Now here the subscribe and I'm forgetting it. fixed header, fixed header. Variable header of 2 bytes, which is this, is essentially a packet identifier, right? So packet ID, and then what the fuck is this? Variable length header pubback with the payload contains a list of topic filters indicating the topic to which the client wants to subscribe. A topic filter is a subscribe packet payload. Must be a string defined by this. Okay. Subscribe packet payload format. Length topic filter this is where the blog will come handy. Is there any explanation? Creating a pack module, we should include it in the source. There is no explanation. At this point, we have two modules, one utility for general serialization operations and one to handle the protocol itself accordingly to the standard defined by OSs. What does the post say about the initial structure? Part 1 is the protocol encrypted from scratch. Part 2 is the network. Fuck, this is a lot. Cool. Server, main entry point, data structure, utility, and educational module. So I guess I shouldn't spend too much time on this because there are a lot to cover. If I feel the necessity, like really feeling it to do it, only then I'll deep dive. Otherwise I won't be able to make any progress because getting comfortable with this is gonna take a lot of time, which should be fine. It should be happening with time. Right now because the thing is I can already see the discrepancy in the things that is happening here. The orders are not as it's described in here, so maybe it doesn't matter that much. I don't know, maybe it does, but one thing is clear, I should move quick. I should move fast. So for the next stream, what we are going to do is I'll mostly copy paste things, but I'll try to understand this, what the tuples mean. It's a pointer to tuple. I'll copy paste things and we'll move fast. We'll move fast. I'm not comfortable with this document name. Like I get the hang of it. There's fixed header, variable header, payload, and all of that. I think if I don't move fast, then I would get bored, and if I get bored, I won't be able to finish any of this. Let's hope it's all this will make sense as we move forward. Okay, cool. And for next stream, we'll just finish the coding this part first, this protocol thing. I'll try to finish the protocol thing. The thing is, he already said in this document that that the trivial part has to be referenced from document. So every type of packet is not here. So when I move forward, I will not find these unset packets. And when that happens, I will be forced to implement those from the official documentation, in which case I'll have to read the documentation and make sense, which is good. Cool. So means we can delegate it for another time. So we'll move forward. Makes sense. It makes sense to move fast and let's just finish this part first without diving deep into the official documentation, because it's always there. If we need it, then we'll see. Otherwise, what is the point of having this blog? Cool. Let's meet some another time. Ta-ta.